feeling good about the standard normal distribution that we started to talk about last time. And I want to start with a quiz. Good morning. So for the quiz, we looked at the z-scores, right? So we looked at section 5.3. I believe the exercise was number 9. And I asked you to calculate the special value, which is called z-square. And the formula for that is, good morning, x subtract mean divided by standard deviation. So in problem 9, we had mean equal to (98.2). Standard deviation was 0.62. And I also created the value of x for you. That was 100, I believe. And with these elements of data, you were asked to put all of them in the formula. So you get 100 minus 98.2 and divide this by standard deviation, which is 0.62. So you want to make sure that these numbers nicely placed in a calculator. So what I mean by saying nicely, I mean correctly. So if you have parentheses around your numerator, then everything should work just fine. So let us put them in a calculator. So 100, we subtract 98.2, and then we divide this by 0.62. And that's the value produced for the z-square, 2.903 ... Some people round it to 2.9, which is fine, but that's the idea of the quiz. So use formula so you can calculate the answer for that exercise. So we had a number of problems that they wanted you to do to show how we can actually utilize the z-scores in the real life situations. I can do problem number 13, so one can see and appreciate this whole procedure that talks about the TV warranty. So let's say if you're in the business of selling warranty for TV sets, you might have pretty good business if you know the mean time for TV to work, which is 8.2 years. And also that standard deviation is 1.1 years. So some TVs work a little longer, some less, but based on mean and standard deviation, you can find the probability here that TV will have replacement time less than 5 years. So we need to find the probability that the TV, so something is less than 5, so that something we'll always call as X. That's standard. And to get that probability, which is going to be an area of the region to the left from 5, since it's a normal distribution with mean at 8.2, then I have to find the area of the region from 5 all the way to the left. And the way we did it, we converted this value of x to corresponding value of z. So if I was able to see what z is equal, then I could actually, based on that z-score, find the area. So 5 will have a corresponding z, so that areas from 5 to the left and from z to the left be the same. And the key idea here is that z-score formula that we just used is what was needed for that. And we have actually everything that we need to use that formula, so that instead of numerator that has x minus mean, I put 5 minus 8.2, and then divide this by standard deviation of 1.1. And parentheses will be used for my numerator. So analogous calculation, just a little different numbers, but calculator doesn't really care what numbers you put in it, right? So it's 8.2 parentheses, and divide this difference by 1.1. So here's the z-score that we produced. It's negative. Not surprisingly, it's negative because we got a 5, which is smaller, so it's to the left from my number, so that 2.9090, etc. actually translates into z-score, which is negative 2.91, right? That's what my z is here, approximately. Notice that I always try to get the closest. That'd be the best approximation to what we need. So going to the tables, remember, we're using tables in this particular chapter. So there are negative z-scores, there are positive z-scores. Let me share these tables with everyone. If you lost the link to it, here's the link. Save it, please. So I need to get a negative 2.91. So the way we use tables is always the same. We need to separate the place of hundreds, which is 0.1 from this decimal, and then remaining minus 2.9 will give us the row, and 0.01 will give us a column. So our area will be 0.0018, which is way less than 1%. So people say if you have such a low probability, well, then there is no chance to actually worry about someone to bring you that TV set for repairs, because the chances of it are very, very low. So what does this tell us? Well, probably that it's a good idea to sell people those warranties and say that if it's up to 5 years, we pay for repairs of your TV. And if it's more, then we don't pay. And the chance that you pay is pretty much zero chance. So it'd be a pretty good business then, right? So that's statistics that helps us to realize it. And same is true for just about any area in the real life cases. there is also part B on this exercise that requires a little bit of modification for the formula for the z-squares. So I can pull out x from it. And to pull out x, I can clear denominator, multiply by sigma my z-square, and get something like that. So you can write it down as another formula that sometimes is useful. Oh, somebody is waiting to be let into class, and I don't know what that means because I'm not sure how can I let someone in the class, because all they do, they just click on the link that is provided in the syllabus, and that's how you get into class. I don't really have any passwords or anything, so I'm not sure where you see that someone can't log into class. I know sometimes people can't log into class because their device does not let them in the class, because they need to log into MDC Zoom, and Miami-Dade College created some kind of thing that keeps people away. I don't know why. So if someone can't log in from one device, try the other device, because I have nothing to do with this, really. And the best place to ask for help is library. So on campus, I guess just have them contact to the library IT people. They usually help, because I think the device they use sometimes it is corrupted or something, so they may wanna, if that's a computer, because I always tell them to use computer instead of cell phone, because with cell phone all kinds of things can happen. But if they use a laptop, just have them to shut it down and get back online, log into only one email, the student email, and from that email they should be able to log in. And if they still can't, then it's a question to ask IT department, because something is not allowing them, and I cannot really say what, because I have nothing really to do with this. That's the college idea to do this. So just tell them to try to shut it down and log back in. So maybe that will help. That's the best I can tell. I know it is frustrating, and I did see some people could not log in from their devices. Devices happen to be too smart, like some of these pads or some that's related to Apple. I think usually people with this type of devices have issues. So yeah, these things, you never know, because they're always behind of all those devices. So, and I wish I could help with this, but I guess that's the best I can say. Try to make sure you log into MDC student email only, because if you're also logged into some other email of yours, then may not go through. So anyways, let's go back to this part B, right? Part B says, how about if you want to provide warranty to only 1%? So you notice that it's way less than 1%. And you say, well, I can provide warranty to more people, because actually, if it's already 5 years warranty to such a low percentage, well, if I raise percent of people, then the number of years will be even more. So maybe it'll advertise my business even better. So what if you have only 1%? Notice that compared to the previous, it's a 0.001. So let's see how this is going to change in terms of years of warranty. In other words, what the X number of years is going to be. So we can take a look at the z-score that cuts out this 0.01 or 1%. So notice that, as usual, if we find the corresponding z to the value of x or vice versa, x to the value of z, then I'd be able to get the number I need. That'd be actually the answer. So I'm looking for 0.01 in my tables. And in these tables, then looks like I need to be careful because sometimes I'm not careful and getting the wrong values, right? So I need to be very concentrated. So notice that once I went down, that road was 0.01, not 0.1, 0.01. That's making big difference. I got this two numbers that surround my 0.01. So I have to select the closest to it. And the question is, which one is closer? Is it going to be 0.102 or 102 or 0.99? So it's like 99 or 102. Which one is going to be closer to 100? Well, looks like from 100 to 0.99, I have only one step, and to 0.102, I have two steps. So definitely that 0.99 is closer, and that's what I have to select. Always select the closest, right? So once you select that closest, you can see the z-score that corresponds to it. So you can see that to this 0.099 on the top, you go to 0.03, and to the left, you go to negative 2.3. So it'll be put together with 2.3, another 3. And this will bring us to corresponding x, and what will actually bring us there is the formula here on the top. So I need to go with x equals to mean. Notice that's still the same exact information from previous exercise. So here's mean, here's standard deviation. So we'll go with 8.2. And then the z was negative 2.33. Plus and a minus means minus. Or you could just put this in a calculator the way it is. People usually like parentheses around negative numbers, so they can clearly be multiplied by that 1.1. So looks like now we're going to be looking at the new calculation. I just want to clean this mess a little bit, right? So let's get this. 8.2. So I just enter all that way it is. And then plus and the minus is just minus 2.33 times 1.1. So we've got the answer. Look at that. It's 5.6 and something. So if you go with 5.6 years, notice that the time is a little bit increased. So instead of 5-year warranty, you can give them 5.6, 5.5-year warranty. Then you will have about 1% of potential TVs to fix. Of course, if someone did not throw it away before a 5-year time of use or before well, whatever, didn't change the TV, didn't buy the new one, and maybe it's going to be still less than 1% of those that kept TV for so long and kept the original documents so they could actually use your warranty to fix it. So I guess 5 years or 5.6 years does not really make much difference, right? So you could just go with 5-year warranty. It's pretty much the same thing, because usually people trying to see what the make consumer happy. So if somebody hears I sell 5-year warranty and somebody says 5.6-year warranty, so 5.6-year be even more confusing. If you said 6 years warranty or 10 years warranty, well, then they will say yes. But I guess 5-year warranty probably sounds pretty much the same as 5.6. So you probably want to just go with 5, right? So anyways, that's interesting. And what's even more interesting, that the next section that we look at is exactly the same. Well, 5.4 is a section that we always skip in this class. So 5.4 is not needed because you can see that you have a bunch of samples. So it's more of the type of estimator type of exercises that we don't really need, as they heavily involved with using computers to help us estimate various things. But section 5.5 is the one that we're going to heavily utilize. So I'd like to clear all of this real quick. So let me get back and look at so-called central limit theorem. I say a theorem, that's some higher level math. Well, not really. It's going to be the same exact story. And I want to just look at the exercise at the end, and you will see that I'm not doing anything different at all. And the name for section 5.5, called as central limit theorem, is just given historically. So let me do problem number 1 and a part A. So you're going to see that we're just going to repeat same process as we already saw previously, because for all of these exercises, information is given here on the top in a blueprint. Mean is 172, and the standard deviation is 29. So with this mean and standard deviation, we need to find the probability, capital P, and in the parentheses, the probability that somebody weighs less than 167. So X is what we always use, less than 167. Yes, we used to have Z in the beginning of this chapter, but that's for a special case when mean is 0. But here's mean is 172. So definitely this is not the case. So we use X. From now on, we'll always use X. So 167 is smaller than 167, than 172. So the area I need is to the left. And looks like I just have to get to my favorite standard normal distribution with mean at 0, right? And I go for the z-square that will cut out the same area, the area that I can find on my tables. So question is, what is the z-square? And the answer is it's X minus mean over standard deviation. That's still the same formula. So let me put 3 numbers in. For X that I'm trying to find the corresponding z-square here, I use 167. And also mean and standard deviation were clearly given to us. They're 172, 100. And and denominator, we have 29. Okay. So numerator needs parentheses, always like that. So let me have parentheses here with numerator. And looks like we just keep going through analogous calculations. And from now on, we will have formula and we will put numbers in. And that's why I think this calculator is so useful, this online calculator, because with it, it's very hard to make a mistake because your calculation is all in front of you. So it's 0.172 ... And then approximately z-square is negative 0.17, right? 0.17 is what I'm going to be looking for in these tables. So we need to have place of those hundreds, and this is going to be 0.7, and also negative 0.1. And I need to scroll this down a little bit, right? I don't see 0.1. So now I see. Okay, so let us do this column. There's 0.07, right? The row is negative 0.1 or 0.1, the same thing. And here's my area. So I found it. Area as usual from the left side, and that's exactly what they're asking us to find. Area from the left. So this is 0.4325. Okay. 0.4325. About 43% the chance for what? Well, they ask that male weighs less than some particular number of pounds. So yeah, so high enough chance because different men weigh differently and everything is possible, I guess. 40% is a good chance, 47%. Part B here is why we have a new section too, because part A is same as we already saw before. In the part B of this exercise, they give us one extra piece of information. They say sample of 36. Remember, sample size is always n. So number of men is 36. So the question is exactly the same. What's the chance or probability that the weight is going to be less than 167? When you say, how can possibly 36 people weigh 167? Well, they're talking about their average weight. So it is a little bit different, even though the picture is going to look the same. So it's 167 or less, and the probability was mean of 172. But my z-square is going to look different because the formula that we used to have, x minus mean over standard deviation, now is going to contain n in the form of a square root of n in denominator. So that's what central limit theorem actually tells us. If you have sample of whatever size, put this square root n in denominator under your z-square. And if one wonders why we didn't do this before, the answer is we did. The answer is our sample size was 1 because we looked only at one man. So if n is 1, then square root from n is also 1. And if you divide your standard deviation here by 1, Well, it's still the same thing. So there was no need in dividing anything by number one, because that's the same thing. But in here, in a case, if you have 36, well, things go a little differently. So let me put these same numbers in again, 167 minus 172, because everything is the same for this. The only change is with my denominator. So standard deviation 29 now is divided by a square root extracted from 36. That's the only difference. And to use a calculator, I need parentheses with numerator as well as around denominator. So let me get a new z-score here. So we have parentheses 167 subtract 172, and then I will divide this by another set of parentheses. And another parentheses, there is 29 divided by a square root from 36. I say, Alex, this is 6. Whatever it is, calculator can also calculate this. So I found the z-score. So let me get a corresponding favorite picture, just like in the previous part. And a z-score is found as negative 1.03. You see that? Negative 1.03. There is 4, but we rounded to 3, right? If 4 follows, then it's still 3. So I take tables and find the column. So in the tables, in the column under 0.3 here, I need minus 1.0. So that's my row, right? And the column, and we have here the area that we were looking for. This area, again, is to the left. It is 0.1515. And that's what we need. So that's the answer. That's our probability, 0.1515. So notice that if you look at the average weight of 36 males, the average weight should be closer to the average weight of all males. Should be closer, so the chances that they be much lower, all of them in average, is only 15% compared to what we had for one male that was 43%. That tells us that one person can weigh just about any number of pounds. It doesn't really, it's not a big deal. But if the whole group of 36 males have average weight much lower than what we expect, well, the chances of that are not high. And that's what this tells us. So the section that deals with samples rather than just one value is here. So where do we use this? The average for people. Well, let's say if you care about people to be put together, and let's say, how about problem number 9? I think that could be a good example. The design of roller coaster seats, because usually there, when somebody rides this roller coaster, it's not just one person there, right? So they trying to fit this with a number of people, and looks like they say they put 2 of them in a row. So let us do problem number 9 here. So they say that They're trying to make sure that people fit on those seats. So in exercise number 9, the average or mean for the width, I guess, of a person is 14.4 inches with a standard deviation sigma equals to 1 inch. Okay, sigma is 1. So the equation is, what's the probability that somebody's hips are greater than 16 inches? So probability that x is greater than 16, that might bring person in trouble, so we don't want any accidents to happen. So if we know that population is normally distributed with mean of 14.4, and 16 is bigger, so somebody has larger sizes and larger or even worse. That's how we think about it. So they say greater than 16. So 16 or greater is pictured here. And for that matter, we use the favorite standard normal with mean of 0 and find corresponding z-square to this. So z will be found by the new formula, which is right here. So let me write this here again. It's x subtract mean divided by standard deviation, right, over square root of n. So now square root of n is involved. When you say, well, for this part, looks like n is 1 because they're just talking about one person. Okay, so we'll put square root of 1. Okay, so x is 16, mean 14.4, divided by standard deviation, which is 1. And you can divide this by a square root of 1, just like that. So we'll be using parentheses. So we put this in a calculator correctly, right? So let's do this. It looks like here we have the numerator. Are you using a calculator? Because I think I will ask you to calculate for a little quiz for today a z-square using this fraction, like 1 divided by a square root of 1. Just like last time, I asked you to practice with a calculator to calculate z-square. So I think it'd be a good idea that you today also try to calculate a z-square. So I just found z, which is 1.6. Okay, so let's go for the probability. Tables are here. Now I need to scroll down because I need positive z-square. So 1.6, where is it located? Looks like it's here. Here's the row. And it's no hundreds, right? It's exactly 1.6. So I go with a first column with a 0 hundredths. So here we have 0.5, actually 94. Why 5? Starts with 9. 9452, right? And that's not what I need, but I can use it to get the other side, the complement. To get a complement, we subtract from 1. It's always like that, right? So subtract from 1, 9452 gives us the answer. It's a 0.0548. This is my chance that someone is not going to fit. 5%, well, some people say it's not very high, but if it's a matter of life and death, then definitely you want to keep it lower than 1% because it's pretty dangerous, right? So should they adjust their seats then or what? Well, let's see what's happening in reality. And I guess there's a part B for that designed, because that's just one person. But how many people will be going together? Well, in the part B, they say each row of 2 seats is designed. So number of seats is actually 2. And then they say, again, what's the probability that 2 men only have min hip of 16? So we need to make sure that same thing happens, but our z-score changed. Notice that z-score is, again, kind of the same calculation, which is already done here on the lower side, but instead of sample size of 1, now use sample size of 2. So I put 16 minus 14.4. And this is divided by 1 over, and now we have a new number, 2. So it's pretty much same thing, right? But not really. So let us go back to the calculator and I'll show you how you can change this real quick. So you can just highlight the number you want to replace, and I do backspace and insert 2, and there it is. So what changed is z-score now is 2.26, right? Because I cut out here. So 226 is what I use for my case. So we can see if probability is indeed any different. If I want to look at 226 and area to the right from it once again, then I need tables. So it looks like we're using tables and we'll be using it a lot. So just, I guess, need to start to enjoy it. So 2.2 is the row and 0.6 is our column. So I got 0.9881. So then on the other side, the side I need will be a complement, 1 minus 9,881. And this is actually much smaller number, right? It's 0.118. So it is about 1%. And again, it's a little different simply because you have 2 people instead of 1 in that row. Because if you have a bigger size person, well, you could just have somebody in smaller size sit next to. And that's probably what happens if you notice in these roller coasters, they have someone who helps people to sit. And it's not that it really helps, but directs them where they should sit. So everything will be safe. And I guess that's important. That's why they keep someone to direct people to sit and pay for that because of safety issues, right? So as promised, I can ask you to do a quiz. Now, what about if I change n to 3? So please find a z-score with exact same setting for numbers. So just like we did already in here, but I'll change n with 3, and I can highlight the calculator here so you can see what was the calculation. So all you need basically is to change your n, right? Because n is here. with 3, then tell me what z is going to correspond to that case. So it's very similar to parts A and B. I don't ask you for a probability. The question is just tell me what z is. Like here we found z, or there we found z, right? So try to put this in your calculator and give me value for z, please.